Live from New York, it's Ask an Engineer Who Has a Cold.
Slightly. Hi, everybody. Welcome to Ask Engineer. It's me, the slightly sick engineer. I'm Ladyada with Mr. Ladyada.
We'll probably get sick tomorrow.
Yeah, you'll probably get sick tomorrow.
Yeah, we'll see.
The baby was sick, now I'm sick, and then it just
That's how it works.
party around the house.
That's how it
But for the
works.
next hour, we're going to be here talking about making, hacking, coding, soldering, messing around with open source, and more. We've got a jam-packed show with lots of stuff, lots of content, including new products, lots of coming soons, videos, and more. Mr. Ladyada, why don't you tell them what's on tonight's show?
On tonight's show, the code is Bus Pirate. We have some in stock. You can save 10% off right now. We'll get to it in the new product section, but if you want to get the new Bus Pirate, RB2350, you can
RB2040.
RB2040, sorry. Numbers. They say the numbers are the first to get attacked by the virus. Bus Pirate 10% off is from the start. We're going to talk about our live shows, including Show and Tell, which we just did, Desk of Ladyada, which we do on Sundays, including The Great Search. We're going to have JP's product pick of the week. We're going to do some time travel, which is looking around in the world of makers, hackers, artists, engineers, news, and Adafruit, and more. We're going to do From the Mailbag, It Returns. It returns. Yeah, new factory for Adafruit, Industry City, and new features, new graphics in our shows, and return of favorite segments like Miller. Gonna do some advanced manufacturing made in Brooklyn factory footage. We're assembling things, so you'll see a time lapse of that. We have some 3D printing. We got a cool speed up video from Don Pedro. We've got Ion MPI brought to you by DigiKey. This week it is ST. We got a whole bunch of top secret.
Whole bunch.
We're going to do some new products. And then we're going to answer your questions. And starting a new feature, we're going to have questions asked across social media in advance, so we have them queued up. And we're going to answer your questions live. We do that on Discord, adafruit.it/discord, discord.gg/Adafruit. All that and more on, you guessed it,
dun, dun, dun.
Ask an Engineer. Okay, Ladyada, let's kick off the show.
Okay. Ooh, I like this little
That's right. Bus Pirates to code. They get free stuff.
Okay, when you order from the Adafruit shop, $99 or more, you get a beautiful PCB coaster with the Adafruit logo. $149 or more, you get a KB2040, RP2040 based Pro Micro compatible board. $199 or more, free UPS ground shipping in the continental United States. And $299 or more, our favorite all-in-one Circuit Playground Express board, which is great for learning coding and electronics. So you don't need any tools or soldering, just plug it right in, get started coding in Arduino, or CircuitPython, or MicroPython, or Code.org, CS Discoveries, Make Code, many other languages. You
don't have to internet debate about which one's best. You can use any of them.
That's right.
Wow. Okay. We do a bunch of live shows. We do them throughout the week, every single week. Tonight, of course, you're watching Ask an Engineer, but we just got finished with Show and Tell. Show and Tell, we kicked it off with Scott. Scott showed a great Scott gadget.
That's right. It's
oddly enough
made in match made in heaven.
Yeah.
USB high speed sniffing using the Syntheon, which we just put in the store last week. So I asked him to check it out, and he was a backer.
Yeah.
And then Jepler came by. And
she was on vacation for 4 weeks in Africa. And the photos are great. But the other thing is, I like to show folks that it is possible to have a job in open source, publish open source code, and have a life and a lifestyle where you're working on meaningful, valuable things for the world, putting it into an open source license for the world to share and do, and have a great life and travel around the world. And that's what Jeff's doing. So Jeff is one of the folks who works on CircuitPython. And say hi and check out all the stuff that he's up to. He's fired up, ready to go, back with a vengeance. We have a
Yes.
bunch of things going in CircuitPython, so check that out. And then Ant showed you know those laptops that aren't laptops, they're the laptop shells and you plug something into it. Yeah, we have a
Lap dance.
tutorial from 12 years ago that I forgot about that we did.
Yeah.
I worked on it with Becky. It was talking about that. And then there's a bunch of other ones that are out there, and we have some guides on how to make those work and more, and showed a Pi, original Pi with that. And then JP stopped by and showed off the power project that he's working on. And then also he found a really old
VT100.
VT100
Classic.
and he's restoring it.
He's destroying it.
So check out
Apparently, don't lick it.
yeah, so check out all those projects and more. And come by, show and tell we do every single Wednesday. You can get a glimpse of what the team's up to, and also you can show and share your projects. On Sundays, we do the Desk of Ladyada. We'll be updating our graphics there. This is a little bit of a preview. On Sunday, we showed a part 2 video of us bringing the Pleo back to life. Pleo was a robot dinosaur toy from like 90. Sorry, no, it's 2000, 2005.
2036, yeah. Right.
Company went out of business, but there's all these Playos and the batteries don't work. So we're showing how to revive them. One of the engineers or people who worked on the Playo posted up in the comments and said, hey, I was in charge of the motion stuff for the Playo, and you're showing how to do the batteries in a good way. So not only did we revive it, but it's kid tested. Here's our kid meeting the dinosaur for the first time. What's that?
Dinosaur.
What's that?
Dinosaur.
Oh, you pet the dinosaur? So you can get those on eBay and then learn how to fix them. Ladyada shows you how. And the Great Search showed all the things you would need to fix the charger and the battery.
The charger, yeah. So
Yeah, it was cool. So don't let those things go to the trash heap. On Tuesdays, we do JP's product pick of the week. Here is this week's highlight. Take it away, JP.
It is the Feather RP2040 ADA logger. Got our Feather RP2040 ADA logger, and then connected underneath it I have a battery and I have a accelerometer breakout board. So what I can do is actually take my SD card and pop that into there. Every second this should be writing a piece of data to that card as this little Lego Jeep I have, little Technics Jeep Wrangler, experiences different accelerometer values. Then I can go ahead and reset that and pop out the SD card, put that into my computer over here. A little graph of that data. So over here on the left you can see these are the XYZ accelerometer readings that were coming off of that board. My product pick of the week this week, it is the Feather RP2040 ADA logger with micro SD card and 8 megs of flash.
And tomorrow's JP's workshop Friday deep dive with Tim Scott's off on Friday. So check in all the innards and more that you can learn about CircuitPython with Tim. So let's do some time traveling. What the heck is going on in the world? So guess what? Monday's a holiday for the Adafruit team. It's a furloughed holiday. Some of them are taken off. Some of them are just storing up that day off. But we will not be shipping on Monday. So what does that mean? Place your orders before 11 a.m. on Friday if you want them to go out, and they will not arrive on Monday, no matter what you do, because it's a holiday. Please, please, please keep that in mind when you're using the discount code tonight. If you're putting stuff in your cart,
just tonight, it should ship tomorrow.
Yeah, just keep all this in mind and how you choose your shipping and how it
Monday is not a work day in America.
Yeah, and then we got news from our friends in the UK. They what is a Twitter direct message called? XM, like I don't know.
Yeah.
What DM? It's a direct message, but I got a direct message from our friends in the UK, Raspberry Pi, and they said, "Guess what? We just saw Adafruit on Dan Aykroyd's show on the History Channel. I think it's just called History now. The Unbelievable." And this one was all about weapons, weird weapons. And by the way, we don't do weapons. This is, and you know, of course, someone snarked on the internet. They're just like, "Oh, we hate weapons." No, we showed the patent for what Homeland Security was doing. They showed how to like make your own and like not have a weapon. So, anyways, I can't show the video. If you go, I have a blog post on it. It's also in our press section. But what I can do is just show the quick speed up of like here's basically what the show was about. It has Dan Aykroyd. There's dolphins with lasers. There's all sorts of stuff. But you can see our flashlight that we worked on that supposedly would make people throw up. It would flash. It's called the Bedazzler. You can look at the Learn guide. And they thought it was funny, and they asked for the footage from us a long time ago, and it just played in the UK. So that's kind of cool. So check out our
We have some guy being like, I feel sick.
yeah. Yeah, and just so everyone knows, if you watch the video, you see me throw up. The way I did it was I got a big sheet of glass and put the camera underneath, and I got a big mouthful of Campbell's chunky soup, which looks exactly like vomit and kind of tastes like it. Okay.
Letters. We get letters. We get tweets and we get emails. Yo.
This is Mailbag. We're bringing this segment back, Lady Ada.
That's right.
So people send us nice notes all the time. We've just been really busy. It's been hard to get them into the show. We say them in our weekly all company meeting called State of the Fruit, but this one was on GitHub, which sometimes you don't have nice things on GitHub, but when we see them, we try to celebrate them because you are what you celebrate. Hello, Lady Ada. Thanks for the swift reply. When I have time, I will do some cleanup and submit that PR. That's a pull request. And before I forget, a big thanks to Adafruit for making all those libraries to support a large community of makers, including myself.
Oh,
Yay! Yay!
Yay.
Yay! So GitHub is kind of nice sometimes. And if you see nice comments on GitHub, hit the little heart button. And you too, out there, can put a nice comment on GitHub, and it'll make it a place.
It's possible.
It's
everyone.
possible.
It's possible. It's
Okay.
possible.
Yeah. That's like it. So we're going to talk about some Python on hardware, Lydia.
Okay.
And you wanted to talk about, because I queued this up. What did you want to talk about this week?
So RP2350 is out. People are starting to play with it, which is great. So there's a new Pi 5 and
Yeah.
2 gigabyte, and we did a new Circuit Python release. We're going to do another 913 very soon. We've been
Okay.
fixing a whole bunch of bugs.
Yeah, the Funhouse build now works. But
Yeah, it was because it uses dot stars and it has like SPI. I don't know. Fix this ESP32C6. Some guides coming out shortly. Lots of new RP2350 boards, and we're going to do some more and more fixes. I love that we already have a die shot of the RP2350 out.
That's cool.
If people want to see the inside, that's like the deep teardown, like a real teardown. A lot of reviews. I like that people did projects with they ran old projects from RP2040 here
Oh.
on the 2350. Mark and Todd, I guess they're teaming up with the round displays. And they're like, oh, this thing from using it on the 2040 now, how does it work on the 2050? And they're like, oh, it's twice as fast, which is about what I've noticed. It's like even though they're both clocked at the same rate because of the FPU, because the M33 processor sort of has like a better.
I like the real world project testing versus like benchmarks. Which
Yeah,
like,
it's
okay,
like-
the numbers more great.
No, but it really is the benchmarks match what we expected, which is
Yeah.
twice as fast. So that's really good. We're seeing more people with 2350, and we got our 2350 Feather PCBs in, so hopefully we will
Okay.
get that into the shop.
Yeah.
soon.
And then one note, shout out to Hackster. They did a Raspberry Pi Pico 2 for CircuitPython Day.
Yay,
It was on Hack Chat.
Hackster.
That was really neat. David Gruden from Make was there. Also, we just chatted with Make. They're doing their board guide. I think there's going to be a bunch of cool Adafruit stuff in it.
Yeah.
We'll see. So very cool. Thank you, Make, for including us. And do check out the rest of the newsletter.
I also like that this plane airplane project on the
Oh, that's nice.
kind of cool.
Yeah. So, get this delivered to your inbox every single week. Adafruit Daily is where you get it. We don't spam. It's a completely separate website. It's important to us to have a place that is free and clear of ads and tracking and all that. Okay, let's talk about some open source hardware news. Everybody's favorite topic.
Oh boy!
Okay, so.
All right, everybody,
All right, everybody.
strap in.
Let me tell you something that's going on. So, a million years ago, I helped work on open hardware definition. It took forever.
Like young and attractive.
It took forever, and a lot of great folks worked on it. And the OSI, they have their open source definition, and they're updating it, and they're looking for community input. And this is their post. Community input drives a new draft of the open source AI definition. Now, here's the thing. Everybody's talking about AI. Um, and it's very polarizing, and a lot of people will just do drive-by hate or drive-by this is the future. Either it's the worst thing or the best thing, and no one is having the conversations about the people that are using these tools in some way, whether it be experimenting or using tools to show how these things work. So the OSI has a good start on their definition. I wanted to see an addition to it, which is basically prompt transparency. And Anthropic is talking about that now. What are the prompts that control these models? And last year, September, Ladyada showed interacting with an LLM. It was ChatGPT.
4, yeah. 4 is
Yeah,
the first good one.
Yeah, and or maybe it was 3.
No, it was 4 because
and-
3.5 sucked.
And she was basically interacting with her own code because it was trained, obviously was trained on her code in some way.
Oh, yeah.
And it was like, hey, I'm Ladyada, that's my code. Like, we're gonna work together and do this library. And we came up with, like, I think a good article, a good video, and showed all of this stuff. And we said, well, how can we be transparent and show what specific things Ladyada said to this LLM, typing, what was the input, what was the output, and then what was the model used, the date, and linking to all this. And ChatGPT lets you link to the logs directly. I don't think anyone's going to show their public logs. We do. And so we have an article, you have video, writing drivers with our Arduino drivers, OpenAI, ChatGPT. And if you look in our GitHub, once in a while, you'll see how we credit. And we're the only ones doing it so far. And, I've gotten some snarks. It's like, well, I'm never going to tell anyone I do this stuff. I'm never going to use this stuff, but people actually are. If you use these tools, I think what you can do as an open source enthusiast is just say how you used them. So the open hardware definition hasn't been really updated in over 10 years. There's a 1.1 draft from 2018, but there's really nothing new that's happened with it. It's kind of frozen in time. There was a logo debate, and I stepped in and helped with this for the gear logo because OSI was like, it kind of looks like our logo, but lucky me, I happen to design the OSI logo, odd series of coincidences. So the idea is for open hardware makers, you would have the ability to say, I used AI in some way. And these are the two logos that myself and our designer were chatting about. And the idea is, and I'll go to, let me go to a browser here for a sec. The idea is you would be pretty clear about what you're doing. So here's the article. It's on the Adafruit site. I'm going to add a couple more things to it. I zeroed in the freedom section, study how the system works and inspect its components. So the OSI definition is pretty good. I want to either add a section to the open hardware definition or have a parallel one that's plus AI. And you don't have to read all of this. I'm just going to quickly tell you like the high level stuff. Inspection of prompts and data transparency. Cool. Prompt transparency, justification and documentation, replicability and testing, prompt and model linking, timestamp and metadata documentation, and public access to logs. So this makes it transparent, makes an environment where users can effectively audit, replicate, and modify AI behavior, which is exactly what the goals of the OSI plus AI is. And I think if you're using any AI tool with open hardware, this is a way to document it. And I was talking to a person in the open hardware community, sort of, I think he's out of it now. But I respect him, and he's like, well, I don't need this because like we don't say what IDE we use and we don't say we do this. So he's more of a practitioner and uses it. We're educators and we have to show people our work. And so for me, this is kind of like what we do anyways. So whether it's needed or not, I think this is the future. Personally, I think we're all going to be using LLMs and tools in some way. So why not have a path for humans to be transparent about it and say, here's the way I can document it. So I contacted OSI last year, didn't hear back, but I did hear back this week, and I posted up in the forums. Contacted Ashwa, hasn't heard back. Generally, they don't seem to engage with stuff like this, like at a 3D printing article. I think they're focused on other things at this time. But Michael Weinberg, who's part of Ashwa, did post on Mastodon. and said Adafruit asked if it's time to build AI in open into the open hardware definition, and there was interesting responses. We'll see if anything comes out of it, and that's kind of where I'm heading. This isn't generative AI, like taking away things. This isn't theft. This is tools that have something to do with AI and how you document them in the most transparent way. That's what this is.
It's not going away.
Yeah. So
Much like software patents, you know what I mean? It's like people are like, oh, can we like somehow like make them never happen? It's like it's too late.
well, the other thing for like the couple jerks out there that discourage anything Lamore does, they show up in all the comments everywhere. We're not going to stop. And why should it just be like tech bros talking about AI all the time? Why shouldn't it be someone like Lamore who's doing something with AI
They're all trained
for
on
open
the code
source
anyways.
for open source code? But it's like, but why? Like, if you hate AI so much, to change it, join in, do something about it. Show how it can be transparent and documented in an open source way. So that's my point of view with this. So we don't have any new guides this week. We do. Let me check Playground now, because I think we merge. Let me check. So guides, you can check Data for Learning System. We have the ones that we just put in like last week, and then for Playground, I think this one might be new using QtPy.
Yeah, this is using the Beetle ID, so it's not.
Yeah.
We don't have our guide up yet.
Yeah, so
it's
do
still
check those out.
early.
And thanks for listening. Check out the open source initiative plus AI definition. Check out the open hardware definition.
They're looking into it.
Well, they have funding for it.
Yeah.
And like there's a lot of interest in this. And everyone's running around there is a little bit of a arms race for like who could be the most open AI, because open AI kind of said it, but then there was Anthropic. Yeah, then there's Anthropic who's like, no, we're going to be the most open. And I feel like in open source hardware, the things that come my way is like, oh, hey Phil, we're going to do a Eagle-like tool that generates Gerbers. I'm like, great, like, but no one's talking about how do you source, credit, license, and document these things, and that's our job maybe. So one coincidence is Adafruit Industries is the abbreviation is AI. So we're now worth 20 billion according to tech.
Right.
All right, let's do some main factory footage. These are us putting our desk together. And that's factory footage for the sweet 3D printing. Let's go straight to the speed up, and then after that we'll go to Don't forget the code is Bus Pirate. Ladyada, we're gonna go right to INMPI. Ready?
Yeah, let's do it.
on MPI.
On MPI, brought to you by DigiKey and Adafruit. Thanks, DigiKey, for making this segment possible. ST is the game.
Yep.
Ladyada, what is the new product introduction of the week? This week.
Okay, this week we're looking at another ST combo chip. It's actually really similar to a chip we talked earlier, which I'll chat about. This is the ST1 V8FE6AX. It's kind of interesting chip because they kind of got really good at making these 6-DoF sensors, and now they're like, well, what else can we shove in here, to kind of broaden the market, because they're so good at making 6-DoFs. So this one has a biosensor front end. I'll say the phrase biosensor is a little bit it's a broad. It's basically a differential input analog digital converter 2-channel, which you can use either as 2 single channel ADCs or 1 differential. It doesn't have an automatic gain control, so you do need some external circuitry, but it's kind of what they intend it to be used as is you can use the extra ADC and filtering and FIFO capabilities of the 6-DoF sensor to basically make a ACG or maybe GSR or some other kind of analog sensor. At the same time, you're doing your IMU measurements, which makes sense if you're doing like a wearable or like a smart ring or smart watch or something. So this sensor, it had, for people who've used the LSM6 series or ISM6 series of ST IMUs, this pinout looks really familiar. You're like, oh yeah, like I know this chip because it's used in the LSM6DS series. They have like dozens of variants. This one doesn't have the external I2C for like an external magnetometer. Also moves a couple pins around. It does have I2C and SPI, 2 interrupts. And there's 2 extra pins called AH1, AH2, Bio1, Bio2. Those are the analog inputs that, again, you'd be used for this biosensing. So this is, again, it's kind of in the same vein of this chip that we covered a couple months ago, the LSM6 DSV32X and the 16X, which is what we liked about that chip was it was their IMU, but it also had this sensor fusion. So this chip kind of builds on it's kind of clearly built on the same like core of the LSM6 DSV16. Like I said, it adds this analog input capability as well. Instead of the QVAR, it does something slightly different. So what it's meant to measure is ECG using 2 probes and maybe like 1 grounding probe. So this would be for like a watch or like a ring, something that has, or sometimes you just have like these little handheld devices where you can just like touch them with your hands, and then you do through the arm ECG, like very, very low. You need very, very high sensitivity for the very, very low signals. ECG signals tend to be on like the millivolt, like plus or minus 1 millivolt signal differential. And so you have to have a really good front end to handle that. This doesn't have that front end, which is like something I didn't realize. You don't actually have the gain front end, but it does have the differential front end. Okay, so the biosensor, what I did think was kind of cool is it does do the low and high pass filtering for you. And it can do FIFO measurements, which I think is pretty handy because you don't want individual points. There's no like value to having the individual point of an ECG signal. You need the whole waveform. So you want to basically shove like 2 or 3 waveforms worth of ECG signal into the buffer, and then you can read it all at once and then calculate, if there's like a fibrillation going on or like what is the heart rate by measuring like the 0 crossings or like the whatever QRST pulses and stuff. You can also change the input impedance, which I thought was kind of nice. Although, like I said, it doesn't have the built-in gain, so you still need to have like your differential op amp to get the signal into a high enough peak-to-peak voltage to read it. So this was actually in the eval board. So this is what's actually required in order to read ECG signal. And I want to clarify this because I did not understand this at first. I was like, oh my God, it has like the 1000 differential gain inside the chip. No, you need to get your quad op amp, and this is a very standard style ECG circuit with some ESD protection in it, because of course it's going to be touching human skin and we're staticky and wet bags of salt. But once you've got that circuit set up, you can get the differential signal in. You'll need like, it looks like a big circuit, but it's actually a bunch of 0201 components and quad op amps. So it's not that big. It's on the back of the eval board. Pardon me, I'm almost a little sick. For the IMU part, which again is like kind of the substrate upon which like they're kind of adding all these capabilities. It's kind of their standard ±2 to ±16 G accelerometer, ±125 to ±4000 DPS gyroscope. Compared to the LSM, the one we showed, the LSM 6DS, LSM 6 DSV 16, it's a tiny bit noisier on the gyro, like a little bit, but it's definitely better than the LSM 6 DS 3TR, the low cost. So it's like, it's not like the highest precision accuracy gyro IMU, but it's definitely not the lowest. It's like kind of mid high range. So it's like good for like gaming and like I said, wearable electronics, maybe not for like really high precision measurement, but it's going to be good enough to tell you like what the orientation of something is within a couple degrees. And like the LSM6 DSV, sorry, LSM6 DSV 16 and 32X, it does have the cool sensor fusion built in. So that's another nice thing. It's like if you're going to do something with an IMU and you think you might want like biopotential signals, you kind of get it for free. And much like using the FIFO for the ECG data, what's nice about this is you don't have to constantly query at like 1 kilohertz or more the accelerometer and gyro data and do your fusion math on it. Instead, what you do is you can set up the circuitry, you know, the registers inside, tell it, do the fusion, and it will give you back your quaternion or Euler numbers. And then you can just get those either from FIFO or on the data ready interrupt. So you, at least you don't have to do the math. The data just spits out. And you don't have to worry about like if you drop a signal, which could increase your error. So you're going to get better performance error wise because you won't have as much drift because you're not losing any signal. You can set it up to be as fast as you want and have it self run. There's a driver available for this chip series in GitHub under the STM Microelectronics. They have a couple of examples for like self-test and reading the VAFE data, and it can like give you an interrupt when the data is ready to go. You know, they're just kind of, I can see they're kind of building a layer cake of improvement.
Don't worry.
Yeah.
Through that.
Okay,
Yeah.
sorry. The valve board is also available. I like that they're kind of building on like the success of the LSM6DS series and just like, okay, what if we like make it red? What if we make it green? What if we put a spoiler on it? Like they're just kind of modding the chip, and each one of them has their own, you know, the one before had QVAR, this one has biopotential differential input. The other one I saw had like audio output. So I think it's cool. I think they're kind of like doing something interesting where they're kind of like gluing together little pieces to make custom chips. But for you, the engineer, it can be really handy because if you happen to need these two circuits in your design, you just like have your bill of materials and it's going to be much smaller, much cheaper because you can use one chip.
Available DigiKey.
Yeah.
That's what we're talking about.
And it's in stock, 2000 in stock, and the valve board is in stock as well.
That's this week's Eye on NPI.
Eye on NPI.
Alrighty, don't forget, we get a code. The code is Bus Pirate, and you get free stuff. But let's go over new products now, Ladyada.
Okay. Okay, coming soon. I have to get the tester done for this. The DS2480-2800. If you like the DS2484, which is a single channel I2C to one wire converter, you're going to love the 82800, which has 8 channels of one wire connected to a single chip that you can communicate over I2C. And guess what? It's even like code compatible with the 2484. It's basically the same driver, except it has now one more command called change channel. Coming soon, we'll probably highlight it again when we get it in stock. But what's nice about this is that if you have 8 temperature sensors and you don't want to like write down the ROM IDs to know which one is which, You just connect one on each one of the channels, and boom, now you've got an easy way to differentiate 8 separate one-wire signals or temperatures, and you can change the I2C address as well.
Okay, and the star of the show tonight, besides you, Ladyada, our community, our team, our customers. It's a bunch of Bus Pirate stuff. So we'll start with the Bus Pirate and then the accessories.
Okay, so first off, yes, the Bus Pirate 5, which I'm super excited about because we carried the Bus Pirate 4
Yeah.
for a lot, or the 3, I don't remember. We've carried it for like more than a decade. And then during the chip shortage, the PIC 32, I think that it was using, got like kind of impossible to get. And Ware Labs, Ian Lesnet and team decided let's redo the whole thing using the RP2040, which is the correct chip to use because it's like using PIO, it's super fast. They did a great job. I did like a design for like a circuit pirate, which was kind of like a.
Yeah, we did Protocol Droid.
But it's like
Protocol.
they did a better job. Maybe I think I might rework the Protocol Droid to be some other chip, but this is
Sure.
better. I love that it has a screen. It's got these
Cool.
labeled outputs. That can you go to the overhead because I've got.
Yeah.
Oh.
Charlie, yeah, look at this. What's going on here?
Hold on.
Unfortunately, STEM camera has stopped.
Sorry, I confused it because I plugged it in.
Oh yeah.
Oh, it's totally like upset.
Oh, because you plugged in something.
Ooh, yeah. I
It doesn't
should do
like that. It doesn't like that at all.
Oh boy. Okay, I can't really do the demo then, huh?
Well, it's coming back. It came back.
Okay.
You could turn on the light if you want.
Yes.
You bus pirated
I
it.
bus pirate.
Arg. Okay.
Okay. So this is the I had it plugged in, but then I can't. I could plug it into your thing, but
What is this, a USB-C?
it's USB-A. You could plug into there or something.
I mean,
Should we risk it?
yeah, I'm a little risky. Sure, why not?
Okay. I don't think it's going to destroy your computer.
Bad
It's going
idea.
to hack the system.
Okay.
Because I plugged into this because I thought it was just power, but apparently it should have been ultra-active too.
It does?
Yeah,
Okay.
I guess you can like store files on it.
Yeah, all right.
It was the other way.
So he said, all right. Oh, is it?
This is USB.
It always takes 3 times. Yeah, okay. Let's see.
Okay, thank you. We're live.
Okay. Whew.
Okay, so this is the, and then it's funny, I can turn the light, 'cause it's now so light.
Shows
So
up as a
this,
drive, yeah.
yeah, so this is the Bus Pirate 5. It's got like neopixels. There's no way to just, you have to wait. It actually goes away. Yeah, I can't figure out how to.
Okay, that's cool. That's
Yeah,
fine.
That's fine.
We're
Yeah,
live.
neopixels. Yeah, whatever. It's cool. We're hackers. It's got labeled outputs, and then you can attach like cool stuff to the end here. So, for example, one of the things you can get, I'm just going to show everything up at the same time, is the probe kit. So
Okay.
if you're like, oh, I want to like attach this to circuitry.
Okay, I'm gonna just go through these images of all these different things while you're.
Well, let's go to the probe kit, which is like the second image you've got there.
You want this?
Yeah, so that's what I'm going to show next. So this, and now we can go back to the overhead.
Yeah.
So this is the probe connector. You see it's got this keyed slot. You plug it in, and boom, you've got these really nice silicone cable tips, and each one of them has heat shrink labeling. Wow.
Nice.
Fancy. Color coding. And best of all, the black wire is ground. So that's Sele. And then you also get, hold on. Just dropped it in the kit. You get probes. So these are really nice little grippy probes. Let's check them out. These are your kind of standard logic analyzer probes. Actually, no, wait. Okay. So you can plug this into here. And now you've got your
Beep.
nice grippy probe. You can grab stuff, and they give you lots. And this is kind of, it's like a little expensive, but it does work quite well. And they have a good feel, and they've got good tips, which is nice. And then the other thing you get are these like, I saw like they were working on machining these for like a long time. These are like luxurious breadboard tips. So instead of just having like, 1 by 1 pin, they actually got machined pins. So
Yeah.
now you can plug this into a breadboard and it's like perfect. So very luxurious probes. And then not only do you have these luxurious probes, but there's other accessories. So let's go to.
Yeah, well, we just showed that. And
Okay.
then what else you got?
So this is a thing that plugs in and lets you program wide and non-wide SPI flash chips. So if you have like your 25C32 or whatever, the standard like SPI flash chips that are used in motherboards or configuration chips or like routers, whatever. It's like they're usually used for storing file systems or configurations or data logs, whatever. You can now read and write them from your bus pirate very easily without having to clip or desolder or anything. And I like this. This is just a little like spring-loaded wire outputs. This is good for stranded wire, particularly because solid core wire you could probably just plug in directly, but into the probe cable. But this is you want to make your own wire harness, and I like how each one they have this little silkscreen printing on top, so you know which one is ground and which one is power, and then you have the 8 GPIO.
All right. Well, that's new products. Bus Pirates in stock. You can get it now. This is coming soon, and we have these accessories as well. Good showing.
Indeed, yeah.
Just
And then the main product is with the case. So you get the
with
case.
the case. All right. That's new products. Okay. So here's what we're going to do.
What do you do?
We have questions lined up. We have 2, and then I have 4 already that people started to ask. Don't forget the code is Bus Pirate.
Yeah.
We're going to do some top secret. We have 6 top secrets all together, and then we'll jump over to the questions. So
Okay.
let's jump right in. What's this?
Okay. So this is I think it's the TMF, but maybe there's a typo. It's the 8828. This is a multi-zone time of flight from AMS Osram. So it's a kind of a competitor to the VL53 whatever XX series of time of flight sensors from ST. But I always like to see what the competition is doing because I think like there's a lot of people do time of flight stuff. So I made a breakout for this board.
Okay, what's this?
This is the TCS 34303, which is a CIE XYZ color sensor. And somebody emailed this to us. I was like, that's kind of cool because it's not RGB, it's CIE compatible. So it's like if you're using this with trying to calibrate a camera or a display, maybe you have to do unit conversion.
All right, what's this?
This is a new chipset. So people like, you're familiar with the LoRa chipset. It's like the SX 1282 or 83. I don't remember the part number we tend to use, but there's a new chip that's apparently more efficient and can go farther. The SX 1262. So we made a breakout
Okay.
for this module. It's not completely pin compatible.
What's this?
This is a IRDA codec chip, the TFBS 4711, and I added on a IRDA transceiver, and I couldn't get this to work actually. I'm still working on this.
What's this?
This is the AS7343, which is an update to the AS7341, which is a popular 11 channel spectroscopy chip. This one does 14 channels.
And
More channels.
last top secret. What's this?
This is an ESP-C6 Trinky. So now that we've got the ESP32C6 feather out, I thought it'd be cool to make a little board that just plugs into a USB socket and it can do like little IoT projects for you. And it's like very compact.
All right. That's this week's top secret. We got a bunch. Stay tuned to the blogs and social media. We publish these as we're working on them. Okay, here's something we're changing with questions. So Anne started, and who works on our team, started to say, hey, we have a show coming up. What engineering questions you have? So we get a couple. And then throughout the show, we're lining a bunch up. So we should, over the course of weeks, have a bunch of questions for folks who can't tune into the show live.
Yeah.
So we're hoping to do that. So let's start answering them right away.
Questions.
First question.
Okay.
When building projects, which use battery power when should we use? An LDO, a buck converter, or buck boost?
Historically, I'd just say like, an LDO. Basically, you have to decide what's most important to you: cost, size, or battery life. So if battery life is the most important thing, you don't mind cost. A buck converter is going to be a little bit more expensive than an LDO. It's going to be a little bit bigger, but you'll tend to have better efficiency, although you have to do the math. Like sometimes it isn't. A buck boost you'd use if your battery can either be above or below the voltage you want as an output. So that's common if you have like something that can take either alkaline or nickel metal hydrides, because it's like, oh, it could be as low as like 2.4 or it could be as high as 4 volts. And you want 3.3, you need something that can do both. Buck boosts are going to be more expensive than a buck. LDO is like your voltage input is always going to be higher than the output, and the heat dissipation is an issue, and you want lowest cost, lowest price, lowest size.
Next question. What kind of project would be good for people new to hardware projects? Should things that need soldering be avoided, for instance, or should we spend time getting decent at that before diving in?
I'd say if you're really new, I would pick up something solderless, like a Circuit Playground Express or like a Pico with headers. Even breadboards I think are tough. I would like a Circuit Playground Express with all-in-one board, something that has everything built in.
I wouldn't bundle your electronic journey with a chemical process like soldering.
Yeah.
Keep those separate.
Like we have like the Pi Badge and the Pi Gamer. And
Yeah, there's Stemma now, and you can do all the things you want to do. And then later, use a proto board.
We have like a Feather with a TFT built in. It's like you don't even need to, I would do something where you don't need to connect anything.
Get far with the things that you can do, and then separately, get a fun kit that doesn't matter if you're good at it.
Yeah.
That's our suggestion. Okay, let's go to the questions that have been added to the show. Okay, first up, on the ADS 780/30, is it normal for other channels to jitter when one hits full VREF or ground? Is there a way to prevent it?
Well, you have to have something. You can't have them floating. If they're floating, then yes, it's gonna, there has to be something driving it.
Okay.
If you are injecting voltage into ground or VREF, it will affect the reference voltage, and it could affect other channels. That could be happening, but I think if they're floating, then yes, of course, if you hit the top or the bottom, you're going to move the other channels around if they're not tied to something.
Okay, is Adafruit Investigator using SAC or GAN, or are these ICs only meaningful for AC or high voltage DC? I'm curious if BJT transistors are now frowned upon for all but audio.
I don't do anything that has that much power dissipation where I need like the efficiency. These are definitely like buzzwordy for power supplies, and like that's where they should be. We need very high efficiency power supplies. I don't really tend to do that. The kind of stuff I do usually has the transistors built into the chip. And so whatever process they use is what process is going to be the transistors, but we're not pushing around 100 watts.
Okay, so this person has a lithium ion battery from an old device. All it says is BAT 1002-1, 1800 milliamp hours, 6.7 watt hours. Will it work with the Memento camera? Works with their Metro ESP32S2, so
6.7 watt hours divided by 1800 is like what it's like. It is around like 3.7 volts. As long as it's a 3.7 volt, 4.2 volt battery, it'll work fine with the Memento. Just make sure the polarity is correct.
Okay. Question: I've seen people replacing old nickel, is it cadmium?
Yeah.
Cells by nickel metal hydride and batteries of old stuff like PowerBook Max, which I'm quite sure isn't very safe. I wonder if it's possible to design a interposer BMS to make the original charging circuit think it's okay while making it safe. If I understood the charge curves of NiCad should have higher voltage when charged, so maybe it's not possible. Plus, I don't have a fancy spot welding cells and a battery I'd like to use 2 times a year, so I'd have to design some thin holders.
I don't know that it's necessarily unsafe. I mean, nickel metal hydride and batteries are like very resilient to abuse, which is why they're okay for people. I mean, I'm actually kind of surprised nickel cadmiums were. I mean, we were so desperate for rechargeable batteries that we're like, oh yeah, let's get poisonous stuff. Nickel metal hydrides are much better. I think even if it's only like 0.1 volt above, I think it's okay. And I'm not sure. I think nickel cadmiums were also, they're usually constant current. and then constant voltage. I actually think you might want to check. I think that nickel metal hydrides actually have a slightly higher floating voltage of 1.25 instead of 1.2. So that actually might be preferable. So you should be okay. Basically, as long as the voltage is and the capacity, the voltage is lower, the capacity is higher, you're good to go. To be fair, the chargers on these were not that great. They're not like
Okay.
they're not gonna again, it's not 100 watts. It's probably trickle charging it with like 200 milliamps.
Any chance Adafruit will make microcontroller board variants that have support for lithium iron phosphate chemistry batteries?
No plan. I think I was asked the same last week. No current plans, but I like that people are trying other battery chemistries. These are safer. But the fact is, most people still want light poly.
Feel like we've all been waiting for some leaps in battery technology.
Light bulbs are like they're not super safe. I prefer that people used whatever lithium, lead,
Yeah.
potassium, whatever it is, phosphate. But yeah, I don't. It's they're much heavier. Most people don't want that. They're used in scooters, just direct and bicycles, e-bikes.
Them's our questions. So if you want throughout the week, look for any place on social media and let us know what question you want answered. Harder the better because we have more time to help out with an answer. And sometimes maybe we'll show some diagrams or a video or we can do some research. But Lady is really good answering these pretty fast, even when she is sick. So before we go, yeah. Before we go, another reminder, the code is BusPirate. There's free stuff. Use it or lose it by midnight tonight. Thank you so much for joining us. We are supported by you. We don't have any loans or venture capital. We just pay our team and all the things that make our team go by the things that you purchase. Thank you so much.
Thank you so much.
This has been an Adafruit production. Here is your moment of Xeno. We'll see everybody next week.
Achoo.